G'day everyone and welcome to Commsverse. This session is called Preparing Your Network for Microsoft Teams, and today will be presented to you by Lee Ford, a fellow MVP. Lee, over to you.
Thank you, James. So today we're going to talk about preparing your network for Microsoft Teams. So quick note about myself. My name is Lee Ford. I'm based in Birmingham in the UK. I'm a solution architect for a company called Simity and mainly work with Microsoft Teams. As James mentioned, I'm a Microsoft MVP with over 15 years of experience in UC in various forms. And predominantly now it's Microsoft UC is what I focus on. You can follow me on Twitter or go to my website if you want to gather more content on something like this session. So before I start, there's a big thank you to all the sponsors that have made this event possible. Without their sponsorship, this wouldn't be possible. So today it's around preparing your network for Microsoft Teams. I'll give you a brief introduction on the session just before we start. This is around preparing your network for Microsoft Teams and a well-designed, functioning network is key really to ensuring that you get a good experience for your end users using Teams. If you sort of ignore this aspect and just roll out Teams and cross your fingers, a lot of the time it's going to end in a poor experience. So it's, in my opinion, it's something that you should be looking at on every deployment of Teams. So this is not an you don't need to be a network expert to enjoy this session. This session is around learning key concepts around preparing a network for Teams. You don't need to be a Cisco certified engineer or anything like that. It's ultimately just what I would call the basics. And if you follow these basics, hopefully be in a better position than if you hadn't followed them. So I'll cover some key networking concepts when it comes to Teams. Teams, as you probably already aware, is a Microsoft product. It's based in the cloud in Microsoft Azure. There is no on-premises equipment as far as servers or anything like that goes. So it's 100% managed by Microsoft. What you need to have is obviously internet connection to Microsoft Teams. So any user that's using Microsoft Teams needs to have access to the internet. And in addition to that, Microsoft have built Teams in a way that the recommended path for a client or a user to connect to Teams is through local internet breakout. And we'll cover this in more in another slide. But ultimately, the intent is that every user connects to their most optimal path to Teams, and you're not kind of funneling everyone down the same path. And the reason for this is that rather than having say a set path for every user to go down, that might not be the most optimal. And in a lot of cases, the traffic is the intent for Microsoft is to get your traffic onto their network as quickly as possible. So if you've got a user based in the UK, you potentially want them to be connecting to UK services and then routing to the Microsoft Teams service, which might not be in the UK, it might be in Amsterdam or Dublin or wherever. And the intent there is that you are routing the traffic through Microsoft dark fibers or private network without having to route that distance across the internet. So I've got 10 recommendations today. These are a mixture of preparing your network, making actual changes to your network, and then also analyzing your network or potential network impact by using Teams. You don't have to do all of them. You don't have to do any of them if you don't want to, but I would strongly recommend that you at least have a look into some of them. So let's get started. Number one, this is probably the most critical one, is making sure that all Teams traffic is allowed through your network. I don't see this as an optional step. And what I'm talking about here is that if you've got a Teams client running on a machine, you need to make sure that they can connect to all the different Teams services without getting blocked or routed incorrectly. And you might ask, well, how do I know where to go? What do I need to allow? How do I find this out? The link in here, or if you just search Office 365 URLs, you will probably find it, is an extensive list, but it is a required list that gives you all the URLs, all the IP addresses and ports and everything you need to be able to allow that traffic through your firewall or your proxies or your network equipment and not block it. That's basically what the list is here for. And if you look at the example there, we've got ID 11, we've got a category of optimize, which means that the traffic has to be handled in a particular way. It's not just a case of allowing it, you actually need to handle it correctly. So if we look at the table below there, we've got optimize, allow, and default, and those are the three categories that Microsoft will tag against the traffic for Teams. So optimize means that traffic shouldn't be going through a proxy, it should be bypassed. It shouldn't be going through any SSL decryption or deep packet inspection or any content filtering. It should just be allowed to bypass those mechanisms. And also that traffic should be using a local internet breakout. It shouldn't be going across a WAN before breaking out. And similarly, we've got allow, which is a similar set of options. However, bypass proxy is not required for that. And then we've got default, which doesn't adhere to any of those. Those are the three basic differences. That there are more subtle differences between them, and they are handled in that URL, outlining what each one entails. But that's the sort of the key concept around the traffic. You're not just going, okay, allow it and let it pass through all your proxies and everything like that. You probably still will have a bad time. You need to be taking a bit more care with that traffic. And an important note is that these URLs, these IP addresses, these ports, and indeed even the screenshot that I've got here does and has changed, and it probably will change in the future. So you do need to keep an eye on this. So don't just set up all the rules and think, okay, great, yeah, that's that job done, never need to look at it ever again. You will do if you want to maintain a good experience. So there is, to help you with that, there is an API or web service that you can query, and that will list any updates or any changes or any deletions, and that allows you then to be able to keep on top of any changes and go, okay, yeah, that change doesn't affect us. Okay, we don't need to worry about that one. Or no, hang on a minute, that's a change that we do need to implement. We need to get that changed on our firewalls and our proxies and whatnot. That service is there for you. In addition to that, this API is also used by some vendors, such I think Palo Alto and maybe Fortinet, to mention, where they will effectively poll that service for you, and then they will update any rules on your equipment for you. And on the previous slide, we mentioned about bypassing proxies, and as a whole, Microsoft's rule is that don't use proxy servers for Teams traffic if you can help it. It's not always possible, but absolutely the ones that are classed as the optimized category on the previous slide really do need to be bypassed. And as Microsoft have outlined in the screenshot, you will get performance related problems if it, such as latency and packet loss, if these proxies aren't bypassed. And the reason for that is that the proxy kind of inspects the traffic and handles the traffic and maybe malforms the traffic on its route between the client and Teams, and that can also have a negative impact on the traffic. So this one is, I would say, fairly key, but not as key as it probably once was, which is using quality of service. And quality of service is a very, very high level. It's a way of prioritizing your traffic when passing through a network. So in this example, if we've got something really, really time critical like voice, where the traffic needs to be immediate, you can't have a delay on a voice conversation, it just wouldn't work. So that traffic needs to be given a highest priority of quality of service. And the way it works is, if you imagine you have something like a funnel where the end of the funnel is the bandwidth that's available, you can't fit all that traffic down that the sort of spout at the end of the funnel, you need to prioritize the flow of that traffic through the funnel. So something like voice probably gets higher priority, then video would get higher priority than, say, just standard web traffic. And the way you do that is you tag the data using what they call DSCP tagging, which is a way of tagging or marking the traffic with a particular value, and that will tell any network equipment that this traffic is to be given a higher priority than, say, web traffic. Just a side note on this, that is, quality of service will only work within a corporate network. It won't work across the internet. So if you have obviously, users breaking directly out into the internet and they from home, quality of service isn't really going to do anything for you. Where it's useful is when you have a large network or a WAN connecting two offices together or multiple offices together. That's where QoS is useful, because it's allowing you to manage the network traffic within your corporate network. As I said, as soon as it leaves your network and goes out into the internet, there isn't any quality of service, but you can certainly manage the bits that you are responsible for. So there are 3 ways to apply QoS when using Teams. The first one is actually using the Teams client to tag the traffic for you. And by doing this, you're classifying, you're turning on the insert quality of service markers, and then that's classifying those 3 port ranges there. We've got audio and video and screen sharing. Those are the 3 sort of time sensitive or time critical streams that you want to be prioritizing. And those ports, you'll see in a minute, are critical to know what those ports are set to when applying QoS. So in this scenario, we've basically said to the Teams client, whenever you make an audio call, tag your audio ports with priority for, the highest priority for voice, and then video and screen sharing, lesser priority but still a higher priority than standard traffic. There are 2 other ways you can configure your network equipment to tag the traffic, and in that scenario, you're using the source ports that were on the previous slide. So you're saying anything between these port ranges from any client subnets, we will tag that traffic on the network side. So you're looking at source and destination ports and matching the traffic that way. That's useful in scenarios where you don't have the team. So something like an iPhone or an Android phone that maybe won't do the QoS tagging for you. That's a useful way of capturing those sort of devices that aren't going to be marked with the desktop Teams client, or a client in a web browser probably wouldn't be captured either, because that will be separate. And then the third option is using group policy object. Obviously, this is Windows only, so this will only work on the Windows desktop app. It won't work on your mobile clients or your Mac client, or if you're running it through a browser. So this is purely Windows client, but it does work and people do use it, and it's another way of capturing that traffic and giving it a priority. The one benefit of doing it this way over the first method, by clicking the checkbox in the Teams admin center, is that you can set the priority, whereas on the previous slide, if we look, we can only turn the markers on. We can't actually set what values are going to be used, and that might not be an issue. But if you need to adhere to particular markings for your network, then that's not going to do. So in here we can set what they call the DSCP value, whereas something like 46 is what they call expedited forwarding, which means it's given the highest priority, whereas something like 34 is a little bit less, but ultimately higher than standard data. And as part of the QoS setup, you can verify that traffic. If you use something like Wireshark, you can capture the traffic from your client and just confirm that the DSCP, the diff serve code point, is set to 46 or expedited forwarding, which means that traffic is then being tagged appropriately. So we can see here that the destination is the destination is Microsoft coming from my machine, and the source port is 50,012, which falls within the audio range, which should be set to 46, which it is. So it's one way of verifying the traffic is being set correctly. So I think we've already touched on this in previous slides, but another key thing is making sure that you're breaking out of local internet connections. Now, if you're breaking out somewhere else within the same country, it's probably not a big deal. But there are certain cases where that's not always the way it happens. So in this example here, we've got a company with 3 locations, headquarters in Madrid in Spain, and there we have the Frankfurt and London offices sending all their outbound traffic via the Madrid office to break out into the internet, to then go back up to Amsterdam and Dublin, which is the sort of the key EMEA hubs for Teams and Office 365. In that scenario, it's not really the optimal route for users in London to actually route all the way across a WAN down to Madrid and then back up over the internet, straight back up to Dublin. It just doesn't make sense. And same for Frankfurt. It's not the ideal path to take. And the reason this solution is used is generally it's for things like cost saving exercises, or it's just one firewall to manage or report on, or for security reasons they want everything to route via a particular location. But it's not always the optimal way to do it when Teams is concerned. Another scenario is where we have VPN users. Obviously, at the moment, that's quite a common scenario where you have users that will be dialing into a corporate location to access services. Obviously, Teams being an internet-based service, it doesn't actually require a VPN to work, even in a corporate environment. Ultimately, that traffic doesn't need to go via anything within the corporate network. So in this scenario, we've got 2 users that potentially might want to contact each other, and rather than using the internet to connect to each other directly and kind of have that call between Manchester and London, that call then is having to go through Madrid and then out of the internet into either Amsterdam or Dublin to route the call between the 2 users, which isn't really optimal. And the reason the way this is configured is what they call split tunnel, not split tunnel VPN, where they are effectively routing all traffic to in this case Madrid, rather than what they call a split tunnel, which means you can go, okay, route all the corporate traffic to Madrid, but any internet-based traffic route locally. And that's what should happen for when using Teams. But in this case, it isn't, and users are going to get a poorer performance than if they were breaking out of the local internet connection. So following on from that Manchester and London user setup, where you've got 2 users that are within the same country, but they the call routing isn't always that way, or that is or taking the most optimal path. So in this scenario, we've got a peer-to-peer call. So when say the London user calls the Manchester user, they will do what they call an ICE negotiation or a media negotiation, where they will say to each other, oh, by the way, my internal IP address is this, and the other one will give their internal IP address, and they will try and negotiate a direct connection. That's the preferred method when communicating between 2 clients, is always to go locally. And that's fine if you have users in the same location. It makes sense. That traffic doesn't need to go out your network. You can manage it. You can do QoS. You can do everything. It's great. Again, if you've got a WAN connection that's between the 2 users as well, great. It's across a WAN. We manage the WAN. We can do QoS. Everything's fine. If that isn't the case and you have what they call an SD-WAN, that's where you have a local internet connection is effectively tunneling a WAN to it's almost like a VPN really. So that each location has a local internet connection, but they're routing all their corporate traffic across that internet connection in a tunnel. So effectively, it allows the 2 locations, even though they're not connected directly, to use the internet to connect internally. So it's almost like a VPN between each other. Which means that when you're establishing a peer-to-peer call, as far as Teams is concerned, these people are locally connected to each other, and that's the preferred method because we're locally connected to each other. We won't break out onto the internet. But in this scenario, that's actually a worse case because we have an internet breakout from London going all the way over to Denmark to go to an SD-WAN hub to come all the way back to go to Manchester. So Teams is thinking that's the most optimal path because they're both on an internal network. But that in this case isn't actually suitable. What should be happening is that traffic should be blocked, and instead the two clients should either be going via a Teams transport relay in the internet, and that would probably be local within the UK for those two users, or you would be a direct internet connection between them. So both would use NAT and they would connect to each other over the internet and have a peer-to-peer call. That would be those would be the two preferred options over this option. And so that's just something to be mindful of, because if you don't block that traffic using an SD-WAN, you will run into this issue where traffic is traversing way further than it actually needs to be, and it's still going over an internet connection. So it doesn't really make sense to be inside the SD-WAN. That should be outside of the SD-WAN. So number 6 is use Office 365 network onboarding tool. So this is a free tool. Anyone can use it. You effectively go to a URL, connectivity.office.com. You say type in your current location, so it knows where you're actually located, and then you enter your domain of your tenant, and then it will go through and it will run some checks to determine where you are located, what services you're connecting to, and is it the most optimal route. And in addition to that, it will also do some quick media checks to make sure that from a media quality point of view for Teams calls, that they are performing as they would expect. So it's not the most in-depth tool, but it's absolutely worth doing on any location within your business. So if you've got 20 offices, I would certainly recommend doing it in each office. Just make sure there's no gotchas. And using this tool in anger, we've come across locations where their internet's breaking out the other side of the world, and we've caught that before there was an issue with we rolled out Teams, and then the latency would be terrible. So it's just capturing that before there's an issue, and it's a very quick and easy tool to run. It takes 5 minutes to do, and it gives you a great visualization if there's any issues. So in this example, I'm based in Birmingham, UK, but my internet breakout is actually in Helsinki in Finland. So the network egress is miles away from where I am, and the exchange front door is also miles away from where I am. And it's basically saying you're as far as where I break out to the internet is breaking out to Finland, so I'm being redirected to the Finland front door, whereas instead I should be going to either Cardiff, Wales, Ireland, Austria, London, etc. That's where I should be breaking out. All these yellow flags is where I should be breaking out, but actually what I'm breaking out is that red cross, which isn't ideal. So the next one is using another tool called Teams Network Planner. This is another key one as far as I'm concerned. What I've seen over the years is that people will just roll out Teams or Skype for Business or whatever communication tool you're going to use, and not properly do a network impact assessment, i.e. not see how much traffic Teams or any other tool is going to generate before rolling out onto the network. And that's not a great thing to do, because people have been caught out where they'll roll out and think, oh, it's not that bad, it won't be that bad, and then it kind of brings the network to their knees and they have to roll the features back, or hastily improve their network, and by that point you've already had a lot of users have a poor experience, and maybe they don't use that tool again because it was so poor the first time they used it. So using this tool allows you to fill in some questions around how many users you've got, what size your internet links are, how sites are connected, and it takes you sort of a few minutes to complete, and by the end it will generate a report based on the information you completed. This is your potential network impact across the internet, this is your potential network impact across any WANs that you have, and based on your current bandwidth that you're using, whether you're going to be across, whether you're going to be above your current WAN usage, or should I say maximum WAN usage. So just a couple of things to note on this is that obviously it's an estimate, it's not exact. They give you a ballpark figure, so it's not absolute. That's what your users are going to use. It's gonna, it's an estimate. I guess it's an approximation based on usage that Microsoft have seen using Teams, but every every company is different, everyone uses Teams differently, so your figures will vary. Don't take it as absolute given that those figures are going to be what your network impact is going to be. It's a projection. So based on that previous slide around estimating your usage, there are ways to monitor your network traffic, and I've blogged about this one recently, where you can use a tool such as Service Map to maybe run on a few machines in different locations and actually determine what traffic is being used and what the maximums are, what the averages are, where that traffic's routing to in the world, if there's any failed connections, how many connections are peer-to-peer, how many connections are going across a media relay, transport relay or a media processor, and effectively compile your own usage statistics. And where this is useful is that you get a better feel for your actual usage, that then you can then put that into your network impact assessment, rather than using the Microsoft Network Planner, or use them in conjunction and go, well, actually, well, Network Planner reckons I'm going to be using this per user, but actually in my findings, it's more around this amount of network usage per user, and from there you can kind of feel, are they similar or are they way off? And obviously this being actual usage, it's probably going to be more accurate than the Network Planner in that respect. So another one around network planning and assessment is using the Teams network assessment tool. So this tool effectively will allow you to run some network tests, or actually run some test calls in the background, and you can run 1, or you can run 20, or you can run 100, I think, and it will effectively run those tests in the background. You don't have to do anything, and then run a report and give you any potential issues that you might have. And this is another good tool to run from every location, running it at different times of day, running it over a prolonged period, and just see, right, okay, is there any issues, at 8 AM on a Monday morning? Do we generally have issues? Let's run the test and see what we're getting back. So this is a great tool just to see if there's any sort of glaring issues. And in this scenario, there's a tiny bit of packet loss, but the round trip time and the jitter, they are fall within the tolerances for a good call. And as an aside, this tool is actually what's used for the connectivity testing tool webpage. When you run that, it does some media connection tests. It's actually running this tool as well in the background. So number 10 is using call quality analysis tools. I can't speak today, and there's a couple of tools here that we recommend you use. One is CQD, or Call Quality Dashboard, and this is a great. Basically, every call that's made within Teams, it captures all the metrics of that call, packet loss, if there's any issues with any microphones or headsets, or what type of versions of clients if we're using. And I think there's about 600 different value or columns per call that are captured or can be captured. So it absolutely has a lot of data in, and using CQD you can effectively report on what you want to see, and then it will obviously give you a better insight if there's any call quality issues. So there are a lot of baked in reports that you don't have to know how to build a report in CQD that are very useful. So things like that monthly trend of call quality there, you can see that the percentage did spike in August, but then it dropped down later in the year. Those are the sort of reports that you get within CQD. It's more high level rather than drilling down into a particular call. For drilling down a particular call, there is call analytics, and this is within the Teams Admin Center. And this allows you to drill down a particular call. So if you have a help desk and someone says, oh, I was trying to join this call and the audio was terrible, or so-and-so was trying to present and the quality wasn't very good, you can drill down into this call and have a look and see what the issue was. So in this scenario, it's saying that the network was the cause of the issue. Sometimes it might be the headset. Maybe they're using a device that isn't certified. That will cause issues. It's a great tool for quickly looking at an individual call that someone's reported and going, yeah, I can see what the issue was here. They're not using a headset, they're using their speakers on their laptop, something like that. It's very, very useful. And that's the top 10 really. So I'll just recap. We've got allow all Teams network traffic using Microsoft URLs that they've provided, bypass proxies where you can, implement QoS where you can, allow Teams to use local internet breakout, don't funnel it down a centralized internet breakout or through a VPN. Be aware of any peer-to-peer routing scenarios that may encounter, so things like SD-WANs. You don't want that traffic routing across an SD-WAN. You'd much rather have that traffic break out of the local internet connection. Use the network onboarding tool to run some tests. Is there any issues with the routing of your traffic? Is the DNS resolvers too far away? Is that going to cause any issues with resolving names to the wrong region? There's lots of different things that tool will test for. Use the network planner to estimate your network impact. If you want a more detailed report, capture that traffic for yourself and see if there's any particular usage patterns for different business units or locations, and put that into some sort of report to work out how best to size your network. And then we've got the network assessment tool. That's key for just running some tests on each site to make sure there's no issues with call quality. And then the number 10 is more an ongoing piece really around verifying that there's no issues with the call quality or user feedback. And I think that is it. Thank you. So hopefully found the session useful and I didn't go through it too fast. If you want to complete a survey, you can go to goteams.fans/survey, complete a survey. I blogged about this presentation previously, so if you want to digest it in a more readable format, you can go there. And that's it from me. Thank you very much. Hope you enjoyed it. And over to you, James.
Thanks for that, Lee. So that was a really good session, actually. It was very interesting to see from my perspective as another Teams expert as well. It's good to see that people taking network configuration seriously. So we've got a couple of questions from the audience here. Henry Phillips asks, if you're setting QoS markers yourself, I presume you want to have the option of turning it off in the Teams admin center, or will it conflict?
You don't have to. You can have it on in both. It just means that the traffic's already tagged before it leaves your machine. So if you've got, I guess where it may run into an issue is if you've got, let's say you've got it manually configured a different way to the way the Teams admin center is going to configure it. So the way I had it was 46 for voice, for example. That's the highest priority. That's what Teams admin center would tag it as. But if, let's say, you have a particular requirement that you can't use 46 for that traffic, it needs to be a different value, then absolutely yes, turn it off on the admin center and implement it yourself a different way.
Okay, cool. Paul Snook asks, are the port ranges for voice and video and application sharing configurable, or are they forced upon us by Microsoft? Any disadvantages from modifying them from their defaults?
There's no disadvantage. So that port range of 20, that's per client. So it's not like you're sharing those 20 ports across your whole estate. So you don't need to worry about, oh, have I got enough ports? That really isn't going to be an issue. It's just if there's a particular requirement within your network that traffic is going to get blocked on those ports or something like that they need to be changed. Otherwise, I would just leave them as default. But absolutely, you can change them. You can change them to whatever range you want. You can make the range smaller. You can make the range larger. It's up to you. But typically, there's no real reason to change it unless there's a networking requirement within your deployment.
And that's all we've got at the moment, unless anybody would like to ask some other questions. Otherwise, we'll head over into the breakout session shortly. But I believe, Lee, you've got another session coming up shortly.
I have, yes. I've got about 10 minutes, I think, before I've got to produce another session. So yeah, absolutely. I've got 10 minutes. If anyone wants to have a chat, then yeah, please do so.
All right. So I'll just post the link for the breakout session in the chat, and we'll head over there. If anyone wants to have a chat or catch up directly with Lee, you can hop over there and chat with us all. Just before we do, though, we do have another question. It is an anonymous question,
Okay.
and they ask if you've been using Power BI for any troubleshooting at all.
Where I've used Power BI is on that report where I was estimating network usage. That's a useful way of kind of getting all that data and visualizing it and putting it in a more readable format than tables of data. Another way is that this call quality dashboard, which I haven't touched on in here, is that can also be output into Power BI. So all the basically all the core metrics of any call that I mentioned, the 600 columns of data, you can absolutely put that into a Power BI presentation and report on it the way you want to, rather than relying on the CQD reports.
All right. I think that's it from everybody. So the link to join up and have a chat with Lee is posted in the chat. It's goteams.fans/BRK111. Head over to there. Lee will be hanging around for about 10 minutes or so. I'll be here for a few more minutes just to wrap this session up. But if you've got any questions, go over there, ask him, and we hope you're enjoying Commsverse. But thank you.
Yeah, thank you, everyone.